Assalamualaikum warahmatullahi wabarakatuh and a very good day. For this week, we will be presenting the lab report of Experiment 7, which is estimation of heat capacity and entropy generation. We are from Group 2 and we are consist of 4 members. Firstly, Nur Imam Aisar binti Kamar Zaman. I am the leader for this week. Next, Farisha Nalia Zainal, Arif Imran bin Ikhwan Surazi, and lastly, Amalia Pemata Aminuddin. For the task distribution, I am in charge with compiling all the slides, do the cover page, and also discussion. Farisha is in charge with the theory and methodology parts. Arif Imran is in charge with compiling all the videos, doing the abstract and also conclusion, and Amalia Pemata is in charge with doing the objective, introduction, and result. So without wasting time, I will pass my presentation to my group members.
So now I'm going to talk about abstract. So this experiment is conducted to estimate the difference in heat capacity and also to estimate the entropy generated when these metals are dropped in a container containing water. In this experiment, heat capacity estimation and entropy generation analysis of heat transfer is performed, in which hot metal is added into a beaker with known volume of water at room temperature, covered with aluminum foil to ensure reliability of the taken data about the temperature change of the water in the beaker. Water in the beaker was heated up slightly as the heat from the metal flows transferred into the water, thus resulting in the temperature change. The temperature change in water is then measured to calculate the specific heat of the metals, then allowing us to calculate the heat absorbed by the water. Heat released by the metal makes it easy to get the heat capacity of the metal to identify unknown metals. After conducting the experiment and doing the calculation, the heat capacity for copper, aluminum, and iron is 0.6756 kilojoule per kilogram K, 1.7622 kJ and 0.812 kJ per kJ, respectively, while for the total entropy generated is 0.0008 kilojoule, 0.0009 kilojoule per Kelvin, and 0.0009 kilojoule Kelvin, respectively. The total entropy generated for aluminum and iron greater than copper. The experimental result is different from the theoretical values due to some factors and error during the experiment.
For the objective for this experiment are, as we can see from the name of this experiment, so the first one is to estimate the heat capacity of different metals provided, which is we have three different metals in this experiment, including copper, aluminum, and iron. So the second one is to estimate the entropy generated when these metals are dropped in a container containing water. Then for the introduction, the heat capacity of an object is described as the amount of heat needed to lift the temperature of an object by 1 degree Celsius. The units of heat capacity are usually expressed by joules per Kelvin. So, as we have learned from the thermodynamics, whereas the entropy generation is the amount of entropy that is generated during irreversible processes. So this generation is caused by the presence of irreversibilities. The value of entropy generation is always a positive quantity. This experiment provides us a heated solid of known mass with the temperature drop in the calorimeter containing a known mass of cold water. After the equilibrium temperature is measured, the estimated heat capacity can be compared with the existing heat capacity to do further calculation to get the total entropy generation value for each metal as a final result.
Hi, my name is Parishan Aya, and next is the theory. Heat capacity is a physical property of matter defined as the amount of heat to be supplied to increase the temperature of the body by 1 degree Celsius. The SI unit of the heat capacity is joule per Kelvin. As for entropy, the definition is a property of thermodynamic system that expresses the direction or outcome of spontaneous changes in the system. Both of these properties can be linked with the second law of thermodynamics, where when two bodies has a contact with each other, the quantity of heat lost by the hot body is equal to the heat absorbed by the cold body, and until thermal equilibrium is achieved. In this experiment, we use equation heat lost by the solid is equal to mc T2 solid minus T1 solid, and heat absorbed by water is equal to M2Cp T2 water minus T1 water, and Cp water is equal to 4.187 kilojoule per kilogram Kelvin. At equilibrium, T2 solid is equal to T2 water. The entropy generation is the amount of entropy which is produced in any irreversible processes. The entropy generated can be calculated using delta S equal to mc ln T2 over T1 and delta S total equal to delta S metal plus delta S water. The value of entropy change of a system or its surrounding is allowed to be negative. However, the value of total entropy should be in positive. The process must be conducted in a direction that abides by the increment of entropy principle as generation is greater than zero. Next is methodology. So the apparatus that we need in this experiment are metal string, thermometer, aluminum foil, iron, aluminum and copper block, beaker, water, hot plate, and weighing scale. So for the first step, the metal block was weighed and the weight for each metal was recorded in table 1. Next, the first beaker was filled with water up to 100 ml. Then the water in the beaker was heated using the hot plate. Next, in step 3, the copper block was lowered inside the first beaker using metal string until it was fully submerged. Then the copper block was placed inside the beaker until the water reached 80 degrees Celsius. We assume the temperature of metal and water were equal. For step 5, the second beaker was filled with water up to 100 ml. Then the temperature of water inside the second beaker was measured. Step 7, the temperature of water inside the first beaker was measured to ensure it reached 80 degrees Celsius. Next, the copper block was immediately transferred to the second beaker using the metal string. For step 9, the beaker was then covered using the aluminum foil to minimize the heat losses to the surrounding. And step 10 is the temperature of the water was recorded for every time interval in table 1 until it reached constant temperature. Make sure to stir the water to ensure even heat distribution. And lastly, for step 11, the experiment was repeated using the aluminum block and iron block using the same procedure.
Okay, so for the result, this is the known mass of water, which is 100 grams. And then this is the table data given with the initial temperature of water 0. And then the known mass of each metals, which is copper 0.1153, for aluminum is 0.0378, and for iron is 0.1105. And then there is the initial temperature for each metal, which is 29 degrees Celsius. There is also the known equilibrium temperature, which is for copper 37, for aluminum 36, and then for iron is 38. So for the result, we have to find the value of specific heat capacity, entropy change of metal, entropy change of water, and total entropy generated for each metal by calculation from the data given. So this is the calculation, and we take aluminum as the sample. So first step is we have to find the specific heat capacity first. So heat loss by metal is equal to heat gain by water. So we can find the final specific heat capacity for aluminum is 1.7622 And then the next step is we have to convert the temperature of metal from from degree Celsius to Kelvin. And then the next step is we have to find the entropy change of metal. So the mass of metal times with the specific heat capacity and with the temperature that have been converted to Kelvin. After that, we can convert the temperature of water from degree Celsius to Kelvin. Then we can find the entropy change of water by calculate the mass times with specific heat capacity of water and then the temperature that have been converted to Kelvin. Then as the final result, we can add the entropy change of metal plus with the entropy change of water. So for this aluminum, we can get the final answer for total entropy generated is 0.007. So we have through all the calculation, we can find the specific heat capacity, entropy change of metal, entropy change of water, total entropy generated for each metals, which is copper, aluminum, and then the iron.
Further discussions. So firstly is to compare your estimated heat capacity with literature or existing data. So for our experimental data of specific heat capacity, for copper we obtain 0.6756, aluminium we obtain 1.7622, and iron we obtain 0.8120. And with the theoretical data for copper is 0.390, aluminium is 0.910, and iron is 0.450. So we compare with calculating the percentage error, which is the experimental value minus theoretical value divided by the theoretical value times 100%. So for copper, we obtain 73.23%, aluminium we obtain 93.65%, and for iron we obtain 80.44%. Next is the bar chart of the specific heat capacity. We can see that aluminium has the highest specific heat capacity, which is 1.7622. Next is to discuss about the total entropy generated during the above process. So based on the result obtained, the value of total entropy generated for copper, aluminium, and iron are 0.008 kilojoule per Kelvin, 0.007 kilojoule per Kelvin, and 0.009 kilojoule per Kelvin, respectively. Entropy is generated due to heat transfer from high temperature medium to a much lower temperature medium, which is an irreversible process. For irreversible process, entropy generation value is always positive, meanwhile for reversible process, entropy is zero. However, a negative value of entropy change is possible. In this experiment, the entropy change of water is positive because it absorbs heat from metal, and the entropy change of metal is negative because it releases heat. Therefore, the total entropy generated increases as entropy change in water is greater than the entropy change in metal. Next is to discuss the source of error and method to minimize the error. So firstly, we have parallax error when taking the reading of thermometer. So the method to minimize this is to ensure eye level is perpendicular to the scale and repeat the procedure at least 3 times to obtain average value. Then, heat loss to the surrounding due to beaker not fully insulated. So we have to ensure that the aluminium foil is fully cover the top of the beaker and insulate the beaker to avoid heat loss. And then lastly, heat loss to the surrounding when transferring the metal into the water. So this can be minimized by transferring the metal quickly into the water to minimize heat loss. Next is justification on the importance of stirring the water in the container. So it is important to continuously stir the water to ensure that the heat is released evenly throughout the water so that the temperature is uniform. And then the justification on the importance of transfer the hot metal quickly into the water is so that it is to minimize heat loss to the surrounding. So since the metal's temperature is higher compared to the surrounding, once it is removed from the beaker, its temperature would gradually drop to the room temperature. So it is important to transfer the hot metal quickly into the water.
Now I'm going to talk about conclusion. In conclusion, different substances will absorb heat at different rates due to various structural factors. The amount of heat lost by the warmer body equal to the amount of heat gained by the cooler body, and the intermediate equilibrium temperature is achieved. From the experiment, the heat capacity for copper, aluminum, and iron is 0.6756 kilojoule kilogram K, 1.7622 kilojoule over kilogram K, and 0.812 kilojoule over kilogram K, respectively. Besides that, the value of total entropy generation cannot be negative, but the changes in entropy of the system may be positive, negative, or zero. Thus, the total entropy generated for copper, aluminum, and iron is 0.008 kilojoule over K, 0.009 kilojoule over K, and 0.0009 kilojoule over K respectively. The total entropy generated for aluminum and iron is greater than copper. The experiment result is different from the theoretical values because some error that might be happen during experiment is conducted. That's all from us.